The complex number minus 4 plus I root 48 is denoted by z. Determine the cube roots of z, giving you the roots in exponential form. So, let's do that. So z is equal to minus 4 plus I root 48. If we sketch that, it's minus 4, so 4 to the left, up root 48. So somewhere there. That's z. Make a triangle. This is 4 root 48. So the magnitude of z is going to be minus 4 squared plus root 48 squared, square rooted. And 16 plus 48, so 64. Square root of 64, that's 8. And then if we work out the arc of z, so we can do tan theta, where theta is this acute angle. So tan theta is root 48 over 4. Root 48 is 4 root 3, so tan theta equals root 3. And so theta is going to be pi by 3. And therefore the arc of z is 2 pi by 3. So at this point what you can do is say that z is equal to 8 e to the 2 pi over 3i. So once in exponential form, so I'm just going to keep it in exponential form. Now we want to do the cube root of z. So we'll cube root z. And so that's going to give us cube root of 8. And then the cube times by the cube root of e to the 2 pi over 3i. Cube root of 8 is 2. And then when you cube root the e thing, you've got to remember that you've got to add the extra root. So I'm just going to cube root it for now. And that's going to give me 2 pi over 9i. That's my first root, but I've got to find further roots. I can say that theta, the angle, is 2 pi over 3, but you can add 2 pi k. So you can add or take away 2 pi based on the values of k. So if k was 0, we know that, so hold on. We need to do this whole thing divided by 3 because we're cube rooting it. So I'm going to divide the power by 3. So if k is 0, I get 2 pi over 9. And if k is 1, I get theta is equal to, so 2 pi over 3 plus 2 pi, that's going to be 8 pi over 3 divided by 3, that's going to give us 8 pi over 9. Now I can see automatically that it's going to go over, if I do k equals 2, I'm going to have to add 6, so it's going to be 14 pi over 9, which is going to be more than pi. So let's try k equals minus 1. And so taking away 6, so that's going to be minus 4 pi over 9. So I'm not going to take this one because that's too big. Remember, you want the values between minus pi and pi. So my answers are going to be 2e to the 2 pi over 9i, 2e to the 8 pi over 9i, and 2e to the minus 4 pi over 9i. So that's your part A, and then in your part B, it says the points which represents the cube roots of z are denoted by A, B, and C, and these form a triangle in the Argand diagram. Write down the angles that any lines of symmetry of triangle ABC make with the positive real axes, justifying your answer. Okay. What we've got, so 2 pi over 9, so that's like 40 degrees, and 8 pi over 9, It's 160 degrees. Minus 40. Minus 80. So my triangle looks somewhat like this. And then I've got my lines of symmetry. And what you'll find is that your lines of symmetry will look like that, like that. And you'll find that all the lines of symmetry actually go through the origin. And that kind of makes sense because each of these values, A, B, and C, are 2 away from the origin. They're equidistant from the origin. And so your origin is essentially kind of the center of the triangle. And so your lines of symmetry will go through that. And the angles that these lines of symmetry will make will be the same as the arc values of each of the points. So the lines of symmetry are going to be at 2 pi over 9, 8 pi over 9, and theta is equal to minus 4 pi over 9. Okay. And one other thing that you might want to know is that this is an equilateral triangle, okay? And so the lines of symmetry are going to go through like the midpoints of the, they're going to go through each of the vertices. I know my diagram isn't very accurate, but yeah, it would look like that.